Muskan, are you there?
Am I audible, right?
Yeah, you are.
Okay.
We can start, Muskan.
Okay. And on behalf of my whole team, welcomes you all for today's session on Industry 4.0. I would like to thank our current sponsors, especially Reliance, competition partner, Hindustan Platinum, our title sponsor, Jai Chemicals, presented by sponsor, Heikel, association partner, Alkyla Mines, the industrial partner, and WAC, our education partner. And last but not the least, all the attendees for joining this event. I hope you all enjoy and learn from today's event. I would also like to welcome our speakers for who took out time from their busy schedule to enlighten us. Mr. Ron Beck, Mr. Pinak Dattare, Mr. Martin Mayer, and Professor Rahul Nabasar, who is an esteemed professor in the Department of Chemical Engineering at IIT Bombay. He has obtained his bachelor's degree from University of Mumbai and his PhD from the University of Wisconsin-Madison. Now I would request Professor Rahul Nabasar to take over.
Sir, I think you are muted.
Okay, sorry. Thanks, Muskan. So, I welcome all the attendees. I'm sure we are going to have an exciting event, and I hope you enjoy the 2 days of Azeotropy. This is the first year where we've had to do it entirely online. But thanks to all the hard work with Kriti, Muskan, Niranjan, and all the organizers, I think it's going very well. So also I welcome all the panelists. And so we have with us Ron Beck of Aspen, Martin Mayer of Zeta, and Pinak from McKinsey India. So thanks for being here on a Saturday. And digitalization is a topic which is quite, it's the buzzword right now in the chemical industry, and there's a lot of discussion about it. At the same time, when it comes down to nuts and bolts, there's a lot of questions. It means different things to different people. So over the next hour or so, I'm sure with with a great panel, I'm hoping to have a discussion. I have some questions of my own, and we'll start off the discussion. But at the same time, please post your questions through the Q&A channel on WebEx. And I'll try to take them, and let's hope we have a very interesting discussion. Okay, so let me start. Maybe I'll put the first question to Ron. He's the one who's had to wake up the earliest, being out in Texas, out in Boston in the US. So Ron, he's the marketing strategy director at Aspen, and to get the conversation started. For the students in the audience, can you describe what the whole Industry 4.0 or digitalization means to you, Ron? Because for a moment, if I play a devil's advocate, we've had the digital with us for a long time in the chemicals industry. DCSs, ERP systems, and things like that. So what's this new digitalization thing that we hear over the last 5 to 6 years so often? As a skeptic, would you say that this is just old wine in a new bottle, or what sets apart this whole digitalization thing? So over to you, Ron.
So yeah, good morning for me, good evening for everyone there, and thank you for inviting me, Rahul, and Kriti and committee and so forth. I'm delighted to be here. I usually make a trip to India at least once or twice a year, but haven't been able to do it for the last 12 months, obviously. Listen, it's a great question, and in fact, companies ask the question also. So there's everybody knows about it, but especially at a management level, I'd say maybe the older people, they're saying, oh, well, what is it exactly? And actually, for the students here, this is a big opportunity for you, because actually, I do think digitalization is something really new, and it's caused a lot of excitement among companies, and it's caused a lot of changes in behavior. So what is it? So we, to put it in the context of the chemical and oil industries and pharmaceutical industries, we sort of invented a concept that we've been talking about for the last year, but actually it came from conversations with company executives, called the self-optimizing plant. And so, I mean, in a way, that's putting digitalization, it's a bunch of digital technologies. And you're right. We also talk about, well, our company is 40 years old. It started making a process simulation tool. And, you know, um, that started, but in reality, and what we say, well, we've been digitalizing the industry for 40 years. So in a way, you're right. But so what's changed? It's the ability to do everything much faster and much more powerfully. So a lot of things people were talking about for years, all of a sudden they're possible. So you had the picture up at the beginning of the fantastic Reliance refinery complex, probably the best one in the world, one of the biggest in the world, definitely the biggest when it was built. Um, what makes that possible? It's all digital technologies. So it's the evolution of these traditional tools into something that can be tied together and can serve the needs of everybody in the company very fast. And in Malaysia, the head of a big integration project there called Rapid, which integrates oil and chemicals, talked about the Industry 4.0 is the democratization of information and decision making. So that's, I think, what everybody needs. As you go to start work in industry, it means everybody in the company gets more information, they can make better decisions, and so it drives the decision process down to the individuals, and therefore the whole organization can make better decisions. And I think maybe my colleague here on the panel from McKinsey will have something to say about it because they put out a paper, pretty important paper actually, about a year and a half ago, basically saying that Digital 4.0 was the next evolution of productivity in industry. And basically they made an argument that companies that didn't figure that out at the beginning were going to be behind and weren't going to be able to catch up very easily because it's so important. And what I see in companies is it's very exciting for people coming out of college because for the older people don't know how to handle it. It's sort of like a 5-year-old, you hand him your phone, a cell phone, and they figure these complicated applications out in about 5 seconds. I mean, that's fundamentally what Digital 4.0 is, the ease of adoption of things and use. Whereas an older person, it takes you maybe months to figure out to teach your grandfather how to do something. So that's where the people coming out of school are being handed a lot of responsibility to figure this out and implement it.
Thanks, Ron. So one of the interesting things, the great things about the panel today is we have somebody from the US, somebody from Europe, Austria, and we have Pinak from India, and also different sectors. I'm hoping Ron gives us the vendor's perspective. So moving on, maybe Martin, to you. So Martin's the head of business development at Zeta, and they have a partnership going on with Siemens. So maybe the question to you, Martin, is you coming from a pharma background. Do you want to add something? What's your view about Industry 4.0? First, coming from pharma, and also, being based in Austria, Germany. A lot of these innovations, Germany sometimes on the leading edge of things. So what are your thoughts about Industry 4.0 and especially the pharma industry perspective?
Okay, thanks. Yeah, also from my side, a warm welcome to all of you and to the organizing committee. Well, I think that Ron was definitely right. I think on the one hand, digitalization is a evolution of things that were going on. And I think these topics were able to be realized. These new initiatives to democratize data were initialized because the awareness of the top management changed in the last years. I think this was the biggest achievement of these last 5 to 6 years of discussing about digitalization, is that it went from a nerdy thing on a mathematician level to a management topic where companies said, well, if we don't catch up, we might be out of business in a few years. So, and this change was, I think, one of the main drivers in combination with, of course, what PCs and software were able to deliver, that suddenly applications were available that you were talking or dreaming about 10 years or 15 years ago, but simply the realization wasn't there. So this is what I wanted to say to the point of Ron, just as a brief idea from my side. Well, what's different in pharma, or is there any difference in pharma? Yes and no. I don't want to stress the actual pandemic situation, but you see how things can run if there is enough pressure. You can even develop a totally new medicine, a new drug, a new treatment without something like 12 months. This was unthinkable 18 months ago. Usually it takes 7 to 10 years to develop a drug and to deliver it to the market. So this was the speed of light. Why was it possible to do so? The first companies, as far as I know, or one of the first was Moderna. I was reading about their breakthrough 40 days after the gene sequencing of the virus. Just imagine that. 40 days after the first gene sequence, they had a cure. This was because they had a certain way how to process, a way how to deal, a platform idea, also based on a lot of digital tools. So there are some highlights, I would say, in pharma that we currently can see where digitalization has a huge impact. If you then go from the drug development to the manufacturing of the drugs, things are a little bit different. Let me put it like that. So since you have this huge effort in getting the permission to manufacture a drug, and any change you apply to this existing manufacturing system is a huge effort in documentation and change, and again, going back to the authority, this is the best argument why people won't change a running system. You know, it's like nobody really wants to change, or at least a lot of people don't want to change. And if you have this huge and strong argument that the authority doesn't allow you to change, you would be willing, but it's no way. This is definitely the downside, and this is hindering innovation quite a bit in manufacturing environments. Means we see digital innovation in pharma when there is a greenfield site, where step by step the digital tools are applied, but the revamping or the rework of existing sites is hardly done, which is definitely to the big sites a downside, because you hardly can go there and put some innovation on an existing site. So this is what I would say around pharma. Europe versus US, India, I think the approach is different. But at the end, I like the combination. I like the curiosity of our colleagues in the US that don't simply feel hindered by what could possibly come when you do it. Like, go look at the automotive industry. There is this brilliant car that made its way around the world. It's almost more a belief than just a car. And it wasn't market ready if you would apply German engineering rules on it when it was produced. And this is where I like US. It's simply just get it done. And this is why I think that we have to combine the good things of both of our approaches. And so at the end, I think also because you named our collaboration with Siemens, there are some global players in the field of digitalization in Europe. Unfortunately, we are behind. Honestly speaking, it's basically the big players are all in US. Then there are some in China. There are some bigger ones in India. And I think Europe is something like a developing country from this point of view. Why did we come across Siemens? Well, we came across Siemens because we, as a company, were a big engineering company, and we thought about how to engineer our process in terms of our engineering process, how to digitize that. And every larger company is running an ERP system. So digitizing your business workflows is something like we know for 20 years now. Digitizing your engineering workflows in the same extent was something like new, and this is why we decided to try out and get it done. And this was very successful. And in this case, we decided to, or we were invited to go into a global collaboration with Siemens especially for the pharma industry to work in a way as an integrator for them, because they deliver the platform, they are the global partner, and we are the integrating partner, like you'll have with an ERP systems.
Thanks.
So I hope
Yeah, go
sketched
ahead.
some of the topics you're interested on the surface, and I'm
Sure.
happy to get more into details.
Definitely. So yeah, let's
So Rahul, if I could, before you move ahead,
Yeah,
I just wanted
sure.
to pick up on very quickly on one point
Sure.
that was just mentioned, which I think is a really important point from Martin. It's the
Mhm.
change and the resistance to change. And that's what's happening in the world today. Everything is changing. And if you look at all these industries, pharma, chemicals, oil, power industry, it's succeeded over many years because of people very slow to change. Like when Martin talked about German engineering principles, you don't put it out until you're sure it's safe. And with a chemical plant, I mean,
No,
they do
it's
the worst.
perfect, not safe. Safe is
All
not
right,
enough.
perfect.
Perfect.
Perfect. Yeah, but that's and now all of a sudden the change is everybody in the world. Okay, the pandemic forced everybody to think about change because everybody had to change fast.
Yeah.
And climate change is forcing everybody to think about change. So all of a sudden, this slowly isn't good enough. And then it forces management to trust, okay, we need to trust that digital things can help us with this change. And I think that's a key point.
Thanks, On. You know,
Good
that
point.
makes sense. So now you know, our third panelist for today is Pinak, and I kept him for the end because I just like to point out that he's from McKinsey India, he's associate partner, but most importantly, he's an IIT Delhi alumnus. So he's on home ground here, right? But Pinak, great to have you here. And so I thought you know, Pinak makes for a great so to have the a consulting viewpoint, because you sort of represent all the end users. So now that we have heard sort of the vendors' viewpoint, the integrators, what do you see when you go out there? You know, is there a hesitancy? Are people adopting it in the Indian context? And do you see any differences across sectors? Say, you know, refining is the traditional use case, but when you go to fine chemicals, petrochemicals, again, pharma, you know, what are the views from the end user? You know, over to you, Pinak.
Sure. So thank you for the opportunity to speak in the event. Good evening to everyone. Pretty exciting and illustrious set of co-panelists, I must say. And of course, good evening to Professor Nabar, to you as well. You mentioned, right, like IIT. I am from IIT Delhi, but I mean, with my JEE rank, I could have really got IIT Bombay Chemical as well. I wasn't getting like crop science, to be honest. but yeah, chose
I
Delhi
did
because it was closer
mention
home.
the fact that you are, you know, you went to IIM as well. We don't mention that out here, okay?
Yeah. No, by the way, my entire family is in chemicals. My father was a chemical engineer from NIT Durgapur.
Oh, wow.
My grandfather was a chemical enginer from Dhaka University. So it's a family of, and a lot of maternal and paternal uncles are also chemical engineers. So, so it's a family of chemical engineers. But yeah, to the point about digitalization, I think overall, we see a lot of adoption. I think 5 years back, it was much more about a hype and we were at the beginning of the curve. But now we see like a lot of adoption going on, right? From medium companies, medium scale companies, say example, 1,000, 2,000 crore turnover, two Reliances of the world, right? And the reason is very simple, because all industries, big or small, they already have the so-called OT systems, with basically the OEM-driven systems, because any production in such a scale and manner, it is usually automated. Right? So automation of systems, particularly in the chemical context, right? Or for example, oil refining, petrochemicals, metal refining, right? Like aluminum refining, steel, so on and so forth. I have worked across sectors, and in all of them, usually the base level of automation is there, which is PLCs, SCADA systems, PI systems, right? Sensors. For example, the steel plant that I was serving, there were 100,000 sensors to begin with. Right now, I'm serving a very leading pharma company in India, and they also have like a reasonably good stack of sensors across some of their core processes. Not everywhere, but in the core processes. The question is, and there is a co-panelist from Aspen here, and Aspens of the world have been like building simulation systems for companies for decades now, right? They are the world leaders. The question is, what is the next wave, right? What is the next wave? And then the next wave is what analytics is what we are seeing in, particularly in the process industry space, right? Not only in chemicals, but wherever it's a process industry. For example, petrochemicals, for example, oil refining, for example, metal refining, we see a lot of value coming from analytics. And when I say analytics, basically it is ensuring and taking away insights from the data which is already there. So a lot of data which is like flowing into the SCADA system and PI system or the OT system, what we typically do is that we ensure larger duration of storage, and then we create all the machine learning models on top of those data. And that throws extremely counterintuitive in some cases, but extremely valuable insights for process optimization and process stability, right? And that is where we typically see that over a course of 12 to 18 month time frame that we do this journey with industries, we are able to affect a 4 to 5 percentage point EBITDA improvement. And so 4 to 5 percentage of EBITDA improvement, 4 to 5 percentage of sales worth of EBITDA improvement, right? And with that kind of an EBITDA jump, really the topic which the conversation that we are having at the early part of the discussion, which is companies who are not catching on to the bandwagon, they will be left behind because their peers are affecting this 4 to 5% EBITDA jump, 4 to 5% improvement in cost competitiveness, right? In the world of chemicals, and all other process industries, it's so competitive that even half a point, 1 basis point also makes a lot of difference. And when we are talking about 400, 500 basis points, it is really a make or break, right? So therefore, it is not a hype. I think it's real. It's real and it's around us. Companies are adopting, and companies are adopting to meet their business metrics, right? Not just a toy. It's not just a toy. It's not just a science project, but really companies are embracing digital and analytics to affect and improve their business outcomes, and that thereby it is critical part of the competitiveness of any company that is there out today. And that's why you see not only a lot of interest in this, but a lot of action as well.
Thanks, Pinaka. That's
I just want to give a comment on Pinak. I'm absolutely delighted. I came across your company in Europe quite sometimes in the last years, and 15 years ago we were doing some, not within Zeta, but I was doing something like what you did, optimizing plants by data analytic tools, but it was driven out of the control domain, and companies like McKinsey didn't even realize what was going on the shop floor level. And these times you had this red and the green people, and you were consulting how to optimize this way of company. You know what I mean? And when I was in Italy 5 years ago, you have a lean manufacturing site there from McKinsey, and I was fascinated how McKinsey changed their approach and how technology driven they are. And suddenly all of a sudden you hear Pinak talking about how large the impact of digitalization, machine learning and stuff is in the context of an entire industry. And this is where I think that you can see that also in the mind change, what happened in the last 20 years, from having the nerds having a mathematical model running a distillation column better or whatever, now to a concept that enables you to be competitive in a better way than if you don't do it. And McKinsey was not there 20 years with this mindset. So I think this is a big change as well.
Yeah, no, I think just a 10-second response to that. So I would say that McKinsey started off as a predominantly accounting firm who started using accounting as for strategy. I think that was the first McKinsey solution, which was using accounts for strategy, which was in way back in 1950s. Then in 1970s, we started doing all the portfolio prioritization and long-term strategy and holistic kind of a growth. From 2000s, I think it was much more about operations, right? So using expert work through process optimization. And the last decade, I think the last decade has been really about McKinsey trying to leapfrog and be ahead of the curve in terms of digital and analytics. And some of the bets that we have taken in terms of acquisition of firms, right? So for example, McKinsey today has 6,000 PhDs on data science on its roles, right? You won't expect, right? McKinsey last year acquired a company called Quantum Black, which does advanced analytics for Mercedes, right? Mercedes in Formula One. So essentially, I mean, the color of the world is changing, and the color of management is changing, and the color of
definitely.
McKinsey is also changing.
No, but just the students won't think about what McKinsey was 25 years ago. It was a top-level consulting company where they didn't, let me call that, they didn't make their hands dirty with the real executing what they gave as a consultancy service. And this changed totally. And this is really where I was so surprised when I saw in Italy how McKinsey changed to really getting down to the shop floor, really doing consultancy on that level. And I absolutely appreciated this, especially in the context with digitalization. We had this out of a pharma context. So there is a Pharma 4.0 initiative running, and this was where we were invited. So I think also this changed a lot, that all these different domains of expertise are much more interlinked. In the last 20 years. You cannot do digitalization without strategy. You can't do it without technology. So you have to include software tools. You have to include know-how, like how to apply machine learning and ML algorithms. You have to have your sensors done, but you need so many different disciplines, and this makes it complicated but fascinating as well.
So on that note of getting your hands dirty, maybe I'll switch to Ron. And we all know Aspen as a process simulator company, as chemical engineers. Aspen Plus is what everybody has heard of. So now when you come into digitalization, and if I go to the Aspen website, there is a bewildering array of products. So what are the offerings on digitalization, and what sort of products, services can you shed some light? How we use Aspen to get into digitalization?
Yeah, absolutely. And actually listening to Pinnock, I'm going to explain it in the context of an example. And it's a concrete example. I think it'll help for the students.
Sure.
And it's actually an example in Southeast Asia, and it's one where McKinsey and AspenTech work together. So I think it's an interesting example. But so what some of the key things we have in quote unquote digitalization. So like you said, traditionally, and AspenTech started with Aspen Plus. I think students probably use it at IIT Bombay. But we have, first of all, we have about 100 different products, which is a lot of products. All the fundamental basis for all of them is models. So there's a model underneath everything we do. So we have supply chain models, we have refinery planning models, we have process control models, we have process optimization models. Everything is a model, really, that are. So if you think about that from a chemical engineering viewpoint, that's what we call first principles. So you build the model from first principles. It's because the understanding of chemistry and physics of chemical engineering. Okay, so now you have analytics, as Pinnock talked about. It's how do you mobilize the data, get value from the data, get insights from the data, and you apply things like analytics and AI. And so the key for us, let me give you so the key for us is how do you combine first principles with analytics? Because if you don't apply first principles in a phone, if you have, let's say, Google Maps, and you put in a place and you don't get there, well, you're just lost for a few minutes and you have to reset. But if in a chemical plant, if you rely on digital technology, analytics and things, and it gives you the wrong answer, the plant can explode. Or in a pharma plant, you can have contamination. So that's where we combine the two. So we have three products that might be concrete to the audience here. So one is something called hybrid models. And what it does is it literally combines first principles with analytics. So it does exactly what Pinnock talked about, that it lets you take, let's say you build a model of, let's say, a polymer reaction. Actually, we're doing that with Reliance right now. Okay, so you take they have a big polymer unit they're having trouble with. It's one of the most sophisticated, of course, because it's Reliance, it's probably the most sophisticated one in the world, but therefore they're having trouble controlling it. So they said, okay, your new hybrid models, which take combined data with first principles, may help us here. So basically, what does it do? It takes all the data streams off of that the real data coming off of that plant, looks at it in the context of the model, adjusts the model, and then gives you new insights. And then it was able to Pinnock's point of view, increase the reliability, reduce the time to switch over from one polymer to another production, make a lot of money in a short period of time. A second area is what we call prescriptive maintenance, so that we have an analytics tool that again combines first principles with machine learning and can predict, let's say, a large piece of equipment in a plant like a compressor. You can now predict 60 days in advance that there's something wrong with that machine, where if it broke down, it would bring down the whole plant. But if you know 60 days in advance, you can take some action in advance, right? And you can also, and it's much more far reaching than that. You can also adjust, let's say, your plan. I know I have to take down this unit in 2 weeks. How do I reconfigure my production to still meet my customers' requirements? And the third area, then we took that's looking at equipment. We have a product called Event Analytics that looks at events. So in other words, in a chemical context, it's upset events. So, you know, some reaction is happening in the wrong way or some other thing is happening. My heat exchanger is fouling. The temperature is getting lower. I'm not getting the right result. That's an event. So those are three products. So now to my example. So in Indonesia, you have Pertamina, which is one of the larger oil companies in the world, in fact, but they have 6 large refineries. And, you know, for Indians, you know, Indonesia is sort of like the sleeping giant there. I mean, you know, in India, you have about 1 billion people. In Indonesia, quickly, it's going to be 300 million. So a lot of people don't think about it, but it's actually one of the most important growing economies in the world. Well, but it's also 1,000 islands. So as opposed to India, where everybody's together, their problem is everybody's spread out. So you've got these 6 refineries. When we go to visit one of these refineries, sometimes it's a 1 or 2 day trip just to get there. You know, you have to take 3 or 4 planes and so forth and so on. So they were having a lot of trouble just keeping those refineries running. So they came to McKinsey and said, what's our problem? How can we apply new technology to that? And they said, okay, well, as Pinnock said, you can apply analytics. And then this is the value you can get. And Pertamina said, prove it. And so then they came to us because we have a partnership and we worked together and implemented something which now Pertamina is very excited about because it works and it proved the value. And so why is that? It's sort of an illustration of everything we've been talking about. You know, it's like, you know, like Martin said, you have to combine strategy. What does Pertamina want for a strategy? You have to apply changing organizations. How do people behave? You know, you can imagine in a refinery that's out in a sort of remote spot in Indonesia, they're not used to using something like advanced analytics. So how do you make that all work? And then it's combining the traditional, which is maintenance, with the advanced, which is machine learning and data. So it's a good example, I think, of what's happening. Yeah.
That's great. So now with that insight, maybe we'll toss the next question to Pinnock. What's the typical rollout of a project? So let's say we have one of these Aspen tools. Are the Indian companies rolling it out themselves with internal talent? Do they go to a McKinsey? Are there a lot of integrators involved? How do they do it?
Sure. No, let me just take the example which Ron was just talking about, right? I am familiar with that example because I've been to these islands that he was talking about. I spent 6 months there. And to share with you, I'm a Bengali, but I'm a vegetarian. So a very unique combination. It was a hard time to survive without chicken, and it was like
you have to just eat fruit over there, right?
Just eat food and on helicopter trips, right? And I used to get really scared about boarding these helicopters. But on that particular example, right? Basically, Pertamina had this goal of doing reducing failures and improving uptime and overall improving OEE. I mean, for the chemical engineering and other students here, OEE is basically operational equipment effectiveness, which is basically how much time is the equipment functioning as it should, right? So that was the business statement, which is how do I improve OEE and thereby get more throughput, right? And by reducing downtime. Now, for reducing downtime, there are two type of levers. One lever is reduce the time of failure, which is to try to rectify it and do it very quickly, which is an approach called SMED, single minute exchange of dice. The other is reducing the number of failures itself. Right? And for reducing the number of failures was that particular problem which McKinsey was working with Aspen, right? Which is we try to create a predictive maintenance platform and thereby predict failures and thereby try to avoid as many of them as possible. Now, with that business statement, there is three sets of work, right? That work part number one is breaking down the entire big problem into small, eatable, palatable bite sizes, right? So that's problem statement number one, which is where somewhere a consultant comes in, right? So like we have like lots of people who are trained in breaking down a large problem into small pieces. The second part of it is basically on the data engineering part, where you extract all the data, you do ETL, right? ETL is extract, transfer, and load, and basically create something called as a flat file, which feeds into the models, right? So, and then you build machine learning models on top of it. This second part is basically the native of data scientists, data engineers, software engineers, and so on, which can be like in-house in the company. It can be like, for example, in McKinsey, it can be like in AspenTech, right? Irrespective of who does this, basically it's a set of data scientists and data engineers who work on the second part. The third part of it is bringing in the domain insights, right? And in this particular example, what Aspen's role was particularly to help McKinsey identify what can be the 120 root causes of failures across equipment, right? So literally McKinsey collaborated with Aspen to create a very holistic library of failure modes, right? And then this failure mode library was actually the crux of the entire predictive maintenance platform. Basically, what the platform was doing is as soon as it was noticing that in the incoming data there are patterns which are similar to the failure modes which are in the library, it was throwing an anomaly, right? So therefore, there are these three chunks of the puzzle, and then there is a final chunk of the puzzle which is change management and adoption, right? So you can have like a very fancy tool and a fancy platform sitting in the operator control room, throwing up alerts, but if people are not acting on the alerts, it really doesn't give any dollar value. And that is where a lot of change management comes in, which is working with the shop floor people, working with the operators, and trying to convince them that, hey, this is different, right? Please follow, right? If there's an alert going in, please go and fix whatever the alert is, right? At least do a check. And the change management is again something that a management consulting firm does, or it can happen also within the in-house consulting teams or in-house digital teams of the company itself, right? So there are these 3-4 discrete pieces which are there, out of which some of them can be done by say a IBM, some of it can be done by say a McKinsey, some of it can be done by say a startup. So competitive landscape and player landscape is actually very varied, but net to do a digital and analytics transformation, there's a core skill set around data engineering and data science. There's a core skill set around the domain itself, be it pharmaceutical, be it chemical, be it like oil refining, and then there's a core skill set around like business problem, breaking it down into pieces, and also doing the change management. So there are these 3 discrete skill sets which like many players bring in, pull in, individually bring in. It all depends on the situation to situation.
So, if I might,
Yes, sure.
great explanation, Pinnock. I think one of the key things you said, which I think is really important to the audience, is you talked about the different parts, like the root causes and the breakdowns and things like that. Well, the concept of root cause, which in other words is what actually caused the fact that piece of equipment is degrading and may break down soon. That's the interface between 2 domains, which in most companies for decades was always separated. And that's really the magic of digitalization. So what you had was you had maintenance people, and they were getting better and better maintenance systems. Okay. And if you look at it, it was like, okay, what is a maintenance system? Well, it was like, okay, I need the spare, this is going to break down every 2 years, so I need a spare part here, I need a spare part there. This, how can I do the maintenance faster, deploy the people better? But that's very isolated. Then you had the chemical engineers who were modeling the systems and saying, looking at, if you will, the root causes. And what everybody didn't really realize, although I think the experienced people knew it, but they didn't know how to express it in the organization, is that actually the main causes of maintenance problems in a plant, it's not it getting older. It's not the age. And everybody manages it by age. If you think about a car, they tell you maintain it every 5,000 miles. That's based on the concept that as something gets older, you need to check it. Okay, but actually in a chemical or oil plant, the main cause of failure is the process itself. We call it process insults, that you're running, the management says, run this at 110% because we have to meet this demand. Well, what they don't know is by running this at 110%, you're just ruining this compressor, which instead of a 10-year lifespan is now going to have to be replaced in 7 years or might break down sooner. So now this gets merged through data analytics, that this equipment's going to break down, but the root cause is this unit 10 steps upstream is running 2 degrees too high, and which is now having a ripple effect on the equipment. And no human being could actually look at all these different data points and ever be able to tell you that's why this is happening. So that's what this is all about. Right? So
I like your point, Ron, because I totally agree. I had an excellent presentation a few months ago where it was about maintenance and predictive maintenance, and one guy was showing the picture of Pope Gregor. He invented the calendar, and they said this guy is the cause why we run our maintenance like we do, because we do it annually. It's like, give me any reason why this guy knows how to maintain a plant. So it was on the funny side exactly what you said. And this is also what Ron said, the learning over the last 20 years, how to combine these domains. This was essential in driving Industry 4.0 to a certain success, because you have to combine and you have to change. Otherwise, it would just be another freaky technology that is available.
So on that note, maybe I'll put a question to you, Martin, that, one of these things is silos within the companies, but now that we have so many different vendors in the ecosystem, I mean, say, let's you want to pull data out of a DCS system made by Honeywell, and your, ERP system is SAP, you have Siemens, you have AspenTech. How good is interoperability? Do we have standards? And I saw that you're a part of the ISP thing. Are things emerging where these systems can talk easily to each other, or do we still have problems in that area?
Long story short, standards would be perfect, but they are not applicable, or they're not available currently. At least they would be applicable, but they are not available. I would.
And they may never be.
Companies that, yeah, exactly. Or it takes you longer to establish them than it takes. Then your problem is gone one day. No, I think it's a little bit depending on the industry, Rahul, because when I listen to Ron, and to Beck, these large companies like oil and gas, big chemicals, they realize that they're just gonna survive if they drive efficiency to the latest level. There are some other industry where this pressure wasn't that early, that high, like also in pharma. In pharma, you usually don't have the pressure. This sounds strange, but when you have a patent on your product, you have some kind of belief of the billions you invested in the R&D sector to create the product. So, and also due to these optimization topics, you're not gonna change what you established during the validation process. This somehow cuts down innovation during the plant life cycle. This also led to the topic that data availability is by far not as extensive as in oil and gas. Because they were running the plant in an automated way, but you have to report these specific reports. You have to prove that your product is safe. But other than that, you weren't allowed to do some counter actions out of the range. So if your product was leaving that range, you simply had to throw it away because you were not even allowed to counteract outside a control domain. So all these topics led to a very, very significant slower adaptation using data for benefit. So this is my industry.
No, on that note, though, so it's great to hear about analytics. But one of the complaints I hear when I speak to people from the industry is, they say, look, it's good to have AI or ML, but I just don't have the data because I don't have enough sensors, or sensors are expensive. It's good for the petroleum guys or the automated plants, but here I have a manual plant or only sections are automated. Do you see the cost of sensors fundamentally coming down on the industrial side of things, like the way it happened on the Internet of Things or in the consumer domain? Is it cheap to get the data out of a process?
I would say relatively yes. It is cheap it's getting way cheaper. Still reluctance from industry to adapt to the really latest technology. Like there are companies that are using a Raspberry Pi for a kind of industrial automation system. Mm-hmm. And this is by far maybe 1/10 of the price of whatever you call the hardware of Siemens, Delta, Rockwell, or whatever. Mm-hmm. And of course, it was always said, yeah, it's not industrial proof and it will break down all the time. Actually, we were using it for applying IoT implementations, and it does not break down, at least not every day, what they try to tell you. So this latest technology, going back from industrial standards, is something that, at least in the industry I have an eye on currently, is maybe on the horizon, outside of the core business, like surveillance of room conditions and these things where they think about applying cheaper technology. And in the core processes, I think change is much harder. Everybody's used to, it's also about how do you act with failures. If you have to decide, Rahul, for you create a new plant and you decide for the automation system, what would you go? Would you save maybe some 500,000 euro, or would you go for one of the big of the big players? You know what I mean?
Right.
It's a hard decision. So I think that in any case, it's getting cheaper, availability is getting better, but it's the driving forces are the big industries that are under pressure of optimization. And as soon as you go to industries that don't have this pressure of scale, that don't have this pressure of being up and available 24/7, also the use of data is significantly lower, the availability is significantly lower, and there you have to think about how to adapt how to adapt concepts to help there. And I think there also the big players are challenged, because you cannot go to a mid-size or a small company with 200, 500 people concept like to a global player. That won't work.
Yeah, could I add one thought here? Yeah, so I totally agree with Martin, and but I think that what's happening is the price of sensors has been driven, like you said, it's been driven down very fast. It's continuing to drive down. But I think the opportunity here, first of all, this is a big opportunity for students coming out of college. It's a big innovation area. I think because data will become, because of all these benefits you're hearing about, the value of having more data and intelligent data is much higher. Okay, so there's going to be a lot of innovation over the next several years there. I think there's also, in the analytics itself, what we do, we have some tools. For example, analytics can tell you if you're missing data, which data is the most, where should you put data? And that's the key thing, because you can't put it everywhere. So if you have X money to spend on adding new data points, where? Okay, and the other part is analytics can test if you're getting the right data, because that's actually one of the biggest problems companies with older plants ask about. How can we test that the data that's coming out is correct, that the sensors are correct? Because there's a lot of problems with instrumentation giving the wrong information, and then analytics could make a decision based on the wrong information. So analytics itself can test. We have tools that test which data is probably wrong. And you think about those those infamous plane crashes with the 737 MAX, it was because of a failure of a sensor. Okay. So how did you, but they didn't know the sensor was failing. Analytics could have told them that. Yeah. So those are all, and then models themselves can help substitute what we call virtual sensors. So can create data points. And we did a great project with VPCL where they created virtual sensors for environmental data. So
it's great that you bring up BPCL, because one of the things I remember reading was about a recent award they won, and it involved I think it was a Kochi refinery, and it mentioned digital twins and also the whole sustainability thing. So and when I read it, I didn't get the connection. But can you comment, how are digital twins bringing about changes on sustainability and things like that? I think emissions reduction or
yeah, I mean that's by the way, we didn't get onto sustainability, but actually, digitalization is a huge driver in industry today. Sustainability is a bigger driver. Almost every company of any size is concerned about sustainability. And in India, it's a huge issue because it's different issues than in the rest of the world, because you're also worried about water. Water is a huge, precious resource in India. And how do you give everybody access to water in India? But anyway, so what they did at Kochi refinery is they took our model. They basically worked with us and built a refinery-wide model to basically calculate how much CO2 and NOx and other things were being emitted all over the plant. And so why is that important? Because it's very expensive to create the measurements. And India, the government, is starting to implement what's called adaptive regulations. So the regulations actually will change depending on the air quality in India. The allowed amounts are going to change. If you're a company with any kind of a plant, how do you contend with that? You have to, and because the measurements today go to a lab. So you collect a sample, you go to a lab. So so basically you can put in a digital model, you can mobilize the data. You don't have all the data points. You can calculate it. The calculation can be extremely accurate because you validate it based on the data you have using this sort of hybrid approach. And then they went to the Indian regulators and said, would you allow us, we can prove to you this data is more accurate than the actual lab measurements. And so it was all agreed. And then they created the system, and it's really achieved three things. It reduced cost of collecting the data, but most important, it increased the timing. So it became available instantaneously. So you could actually manage your plant based on what you knew what was happening, instead of finding out a week later that you just violated the regulations, right? So you can take action right away. So it's a great example. Yeah.
Thanks.
And Ron, you most probably could evaluate new strategies, whether it's a good or a bad impact on the CO2 footprint when you have this model at hand.
That's right. And what you do is you trade off. Okay, because the company's promising to reduce CO2 by 20%, let's say in the next 5 years, can you take proactive actions? We will know from this model that if we run this unit 1 degree less, we cut our CO2 by maybe 5%, but we can still in fact, we can make more money because we actually know what we're doing, so we can run right to the limit. So, yeah.
Maybe I'll take one of let's go to some of the interesting audience questions. So there is a question about startups. Is digitalization going to create or give an opportunity for more startups? So does any of you want to highlight some startups that are in this area and have been doing well, or any thoughts on startups due to digitalization?
Yeah, I could let everyone else chime in, but there are a lot of startups now happening in sustainability. So one is carbon capture, the second is plastics recycling, and the third is around biofuels and things like that. And a fourth coming a little later on will be hydrogen economy. But lots of very small companies, and what they're able to do is, we find out about them because they call up for our tools, and normally we wouldn't even, who are these people? They're 10 people literally in a garage or something starting up. And because with all these digital tools, you can do what maybe a company would take, require a huge investment, a lot of people and a lot of time. Sort of what Martin was talking about with, how did you come up with a cure for a virus? And, in 40 days, it's the same idea. how can you come up with an idea for a new carbon capture approach, but people need it soon. So how can you bring it to market in a year or two? How can you figure out a process to so there's lots of opportunities, and the digital tools let a small group of people do as much as the large group could do in the past.
Thanks, Ron. Thanks for that. So, coming to Pinak, I have a question on the Indian context. You know, all the examples are great, the fancy ones, but when you go to the Indian industry, you still see a lot of companies, some of them, 10 million, $50 million sized, which are entirely manual, and historically in the West, we went through, say, pneumatic controllers, DCS systems, and now we have the way of digitalization. So what is the trajectory going to be for a lot of the Indian industry, which is a lot of SMEs doing a lot of value in, say, fine chemicals and things like that? Do you see them adopt a different trajectory to digitalization, consolidation? What do you think is going to happen?
Yeah. No, I guess with the growth in Indian economy and also in the Indian chemical sector, right? I think companies north of 1,000 crore INR turnover, there's a very significant fraction, right? Companies like Aarti, Ghada, so many, Bedmoney, DCM, Nirma, and then there are the giants, right? Birla Chem, right? Aditya Birla Chemical, Grasim, Reliances of the world. But I've seen even in much smaller, I don't know why, So even in the much smaller sphere, I say the companies who used to be like 200, 300 crore turnover 5-6 years back are all now 1,000 crore plus turnover. That's the extremely fast growth which has happened. And many of them are going global, right? They are not stopping. So very soon I can imagine that in next 3-4 years, there will be at least 10 to 15 companies in India who would be like unicorns. And I'm talking only about the chemical space. Now, if you have companies which are more than $1 billion turnover, $500 million turnover, $1 billion valuation, it gives a lot of license to invest. Right? A lot of license to invest in technology, lot of license to invest in product, lot of license to invest in R&D, right? And as they cater to the global market, right? Particularly in fine chemical, specialty chemical, where exports is more than 80%, competitiveness in terms of not only cost but also in terms of quality is also important. And that is where you will see a very increased trust in automation, digitalization, and so on, because labor laws have to be complied with, and environmental laws have to be complied with, customer preferences will be more evolved, and even the Indian consumer is becoming more sophisticated in its expectations, right? So in all that context, and parallelly with a larger war chest to go into the playground with, most companies are getting highly interested in this. And the benefit of digital and analytics is that it's not like a capex where you need to put in 100 crore, otherwise you don't get anything. You can like put in 10 crores and see a lot of impact, right? So it's almost like you can invest in bite sizes. Put in first 5 crore, get 5 crore of improvement. Then put the another 5 crore, get another. So the market has become more liquid. And you mentioned about startups. There are plenty of startups, but also I would say companies like McKinsey, who are known to be pricey, but actually they also work on a variable model, right? So very limited initial investment, but the companies put in 6 months of very limited initial investment, but the first 6 months of gains finances for the next 6 months of the program, right? So in that model, we see like a lot of companies in the 1,000-1,500 crore turnover range also doing like very significant digital and analytics transformation and changing themselves, right? And that's why the space is very exciting. I think space is very exciting, not only there because there will be a lot of growth, but then the growth will also be backed out by a lot of competitiveness, a lot of international expansion, a lot of improvement in processes, a lot of improvement in the people capability, and all this can be driven holistically. So literally the next 3-5 years, hopefully, we will see a more accelerated growth as opposed to what we saw in the last 5 years, which itself was pretty like 10 to 15% of growth per annum.
Thanks, Manoj. So maybe since I'm on the topic, you studied chemical engineering. So out of all your coursework, switching tracks a little, what sort of courses did you feel helped you the best in this whole digitalization journey, and also as an advice for students and maybe faculty as well? What could we be doing to sort of train chemical engineers better to step into projects of this kind, to digitalize the industry out there? Any thoughts on that?
Yeah, so great question. So I would say twofold, right? One is that a lot of the education that we pick in IIT, it trains us on our problem-solving dimension, right? And probably that education starts even before IIT, right? But our class 10th and 11th and 12th. So generally, I see that you learn problem solving, which is any new place that you go to, you start absorbing the content very quickly, you start ramping up very quickly. So I would say the learnings which I had in IIT was much more holistic. I remember the courses, right? Heat transfer, mass transfer, thermodynamics, fluid mechanics, so on and so forth. But I would say that when I do a project, I refer to the textbook which I used, right? For say mass transfer or heat transfer. I would say the education creates a nice platform. What you learn at IIT creates a nice platform and enhances the core skill set, right? The core skill set of problem solving, breaking the problem into small parts, just thinking about the problem, going to a new place and picking up the content. So that's, I think, reflection number one. I think reflection number two is that on what could be done to make it like much more translatable, that you learn something today and you tomorrow implement. I would say I would encourage courses of just pure data science, right? And that is where I believe really the future is. The future is not like only the computer science students will do data science. The future is that everyone will do data science, right? So tomorrow, even today, when we transform, say, a big or a small company, the parlance and the language of shop floor manager, the shift operator, the executive director, everyone changes. None of them are computer scientists, right? For example, I am a chemical engineer, but today I can model in R, I can model in Python. I am very familiar with all type of statistical techniques. All this I have learned in my last few years. So I would say that to become like the chemical engineer of the future, I think the chemical engineer of the future has to be well trained in math, well trained in coding, well trained in, of course, the chemical fundamentals, but having a much more broader skill set, which includes like data science, machine learning concepts, some bit of software engineering also, because software engineering is not like the domain of computer scientists anymore. It is the domain of everyone, right? Just like we all know how to use Microsoft Office, Word and Excel, I think in 3 years' time, everyone will know how to use R and Python and so on and so forth. So I think it has to become like the core skill set.
Yeah, that's a great insights. So there's another question from Somesh on a different topic. So we've had a lot of industrial accidents in India. So I don't know, maybe I'll put it to Martin or Ron. Are there any applications of digitalization for reducing industrial hazards? Any applications you want to point out where it makes the chemical industry safer?
Well, for sure. I mean, that's I don't know for any. Well, you've been exposed to industry a fair amount, Rahul. But I mean, first of all, just for the students to understand, this is a huge concern of all industrial companies. The public doesn't necessarily know that, but any meeting I go to with a chemical or oil company, they have something at the beginning of the meeting called the safety minute. And often as a visitor to a meeting, they ask you, would you give the safety minute? And then you have to come up with so what does that do? It just makes everybody think about it all the time. Well, so we have a whole set of software that focuses on that. So yes, I mean, there's two types of accidents. Okay, there are what are called process safety accidents, and then there are occupational safety accidents. So I think the occupational safety part, virtual data helps a lot. They're starting to put, for example, sensors on people so that they know where people are in a plant. And one of the big challenges there is, and we don't provide that kind of software, but I think it's really important because one of the big causes of accidents to people is the wrong person is in the wrong place at the wrong time. And the other people in the plant don't know it and they start an operation, which they shouldn't do when anybody's there. So if you actually know you have a little device on you when you go into a site, they know that you're there and they need to get you out of that location before they start that activity. Right. And then the other part is process safety, which again goes back to all the stuff we've been talking about. Analytics, understanding what's happening in the process because there are conditions that build up. So we have models which can tell you how to design it so it's safer, which can tell you how to run the data to understand when you're creating unsafe conditions. But then what you need to merge everything together. The data flows from the plant, run these faster using high performance computing, so that you have dashboards that maybe even are starting to be presented to the actual workers to understand you need to move because you're now in an unsafe condition, or you need to take an action because the whole plant is becoming unsafe. And so if you look at, there's some great videos actually every student should look at online. Probably the best video, there was a famous accident in Texas called the Texas City disaster. There's a plant called Texas City. And it's about a 30-minute video that the Chemical Safety Board of the US put together. And they put this video together, actually the company, I think it was BP who owned the plant
BP,
at the time. They were trying to block them from releasing the video because it sort of shows that actually there were a lot of human mistakes that happen. But one of the things that becomes clear if you look at that video is what really happens is you're there in the middle of the night, which is what actually happened. And there are all these, in the video they show it's a simulation, but they show, 30 or 40 computer screens there, and things start, going red, and there's only one person in the whole control room in the middle of the night. So how does he know which data to look at, which is actually, and that's where analytics comes in if you think about it. If there's so much data, the plants are so complex, now you have even more considerations like sustainability. Are you going to create a carbon release, which is going to get your company in trouble, versus are you going to blow up the plant, versus are you going to miss a production? There's so many different considerations. Analytics and data is going to help. Same thing in pharmaceuticals, right? I mean, I'm not as familiar with that area, but you can make a mistake and ruin millions of dollars worth of pharmaceuticals in 15 minutes by running it wrong, right? So
yeah, maybe I can bring in a different point because we are not so much into operations of a plant. We're more into engineering and then starting it up and handing it over to the customer. And when I came to Zeta, I realized we do everything digital. So you have all your documents digital, all your 3D data, everything. And I said, well, all the industry is talking about VR, AR, what could we do if? And I said, well, we have everything. What can we do with it? And this is talking about how to use it for training, for startup training, because it's there. The physical twin of the plant is there. The process twin is there. At least not as sophisticated, but the base simulation is there. So you can see what happens if people can at least train a little what happens. So it's not as sophisticated what Ron said, but it's at least to get to know what you have to do. It's a new plant. It's not as big as your sites are, but it's maybe some 15,000 new equipment parts, and it's 20 new screens in your PCS. So you have to somehow think about how to handle that. And I think using this data for training is also a use of digitalization where you can at least give the people and the operators an idea when it's critical. And then if you apply some more AI on that when they run the plant, I think this could be a big boost in safety on top of it. How you could do that in companies that start from a totally different level? That's the question. How could you think about retrofitting? How could you also, like what Rahul and I was discussing when in our preparations, like we were thinking about a concept when you start with IoT, where you just measure what's going on, maybe your core process, to be sure that everything is aligned, and then maybe transform this IoT approach to automation approach, which systems as of today don't support. You can't go that way. I know applications here in Europe where they run tunnel safe systems in the cloud. There is no local DCS anymore, and it's about people and safety. It's about traffic lights and accidents, and they run it in the cloud. So you can do it. It's more an IoT solution than a typical control room anymore. I mean, the control room looks the same, but the driving force is not located at the DCS. It's somewhere else. So I think there are new concepts, and as well as maybe an interlink to what Ron said, analytics. I'm a big fan of visual data analytics. If you give the right tools that you can dig into your data, but you as a human, you're the one that says, hey, this looks weird. You click on it and you dig into it. This is maybe a big or a nice, let me say, transformation step between having an AI doing the job and having nothing is just preparing this visual in content. You have to have a subject matter expert. Either how you do it doesn't make sense to the user, but if you do that right, this is an extremely efficient tool, I think.
Yeah. Maybe 10 seconds, Rahul, on 10 seconds, Rahul. I know we are running out of time, but you mentioned about safety, and I'd like to share a story from L&T. That's L&T, as you know, is India's largest and maybe one of the world's largest EPC contractors, right? They have like so many people who die every year, literally fatalities, because they are not adhering to safety procedures. And within safety, one procedure is wearing the helmet, which has been statistically proven to be the most effective. Now, despite repeated reminders, incentive, carrot, stick, L&T was not able to get people to wear helmets. So what they did was actually they circulated AR and VR goggles where they showed videos of people climbing up the pole. And one scenario, he was wearing a helmet, he comes back and meets his family, and everyone is happy. Other scenario, he's not wearing a helmet, he falls and he dies. That literal just AR and VR goggle and video improved the compliance of wearing a helmet by about 90% and helped them reduce really fatalities by a lot. So simple application, doesn't require a lot of data, but really very impactful, right? And those are some of the very niche use cases across domains, safety, environment, health, sustainability, or business outcomes, which I guess all the new realm of digital analytics is making possible for us.
Thanks, Pila. So one of the things we were debating, say at IIT in the department, was to create a digitalization lab, with the idea of exposing students to digitalization. But we were a bit lost about, what should such a lab comprise? Or an alternative thing is, when we talk to people from the industry, a lot of them say, look, we have these fancy case studies, but I don't know where I can go and see, Reliance may be implementing it, but it's proprietary. So are there any initiatives, maybe Ron or Martin, with say vendors coming together or a consortia, and what role can a university play? How do we create, say, these showcase examples where people can actually see digitalization at work? Has this been tried elsewhere, say in Europe, in the US? Maybe some sort of collaboration between universities and vendors where we create from a teaching viewpoint as well as an outreach viewpoint. How do we get digitalization examples out there?
So I think that's a great question. I mean, I think now is a good opportunity time because again, I've been doing a lot of work in sustainability, which is another whole question. We should have another seminar on that soon. No, I think it's important for the students to understand it from how they can influence it as engineers. But what that's causing in the industry, all the industries, is new kinds of partnerships, collaborations. Okay, because like you said, all industries thought of things in a very proprietary way or a competitive advantage way. And all of a sudden everybody realizes, well, sustainability is an issue that cuts across companies and we need new kinds of partnerships. And so I think that's, between everybody, and I think, yes, to answer your question, yes, some people have created labs. I think McKinsey has created some like showcase labs that we've participated in. But I think it would be a great role for a university like in India I know that some of the stuff is proprietary, but some isn't. Why not work with somebody like BPCL, okay, and say, hey, could we set up an instance of this, let's say, emissions thing in the university and let create like an offline version where the students can play around with it and can try new innovations, for example, or can invite other vendors to come in and add pieces on and show how it could add to this data set. I mean, I'm not saying that they would agree to that, but I think it's a really good idea. And I think that this is an area where people are looking at for new innovation, maybe around the carbon capture area where it's a big problem, or about water, maybe a water conservation. Because really, honestly, I think people aren't focused on that enough. And, everybody's looking, for example, at how do we come up with solutions to track and reduce carbon. But nobody's really looking at how do we come up with solutions to optimize water and recycle it in most effective ways. I mean, yeah, different people are looking at it in different things, but, there's no to me, there's no part of the world that needs that solution more than India. I mean, every time I go, I see water trucks driving around delivering to the people who have enough money to afford it, their own private, highest quality water, right? But everybody, I think everybody needs it, right? So that's an important, I think there's an imperative on all the industry in India. They've been directed to come up with strategies to reduce water use. Well, it's not that easy. Maybe you could create a digital lab around that, for example.
Yeah, Martin, any comments? What should a digitalization lab for students look like?
I was just wondering. I mean, we made a 1 year ago, no, 2 years ago, we got back a piece of equipment from the university because the project there ran out and we didn't know how to use it. And so we refurbished it and we decided to use it as a training facility for our new employees, and they know how to engineer and they know how to maintain. And around this physical facility, we established all the IT platforms and software tools that we have at hand. And so we said, okay, this is our area where we are going to develop our new solutions and our new products. And what suddenly was happening was not intended. Suddenly, a lot of sensor suppliers and customers, they were interested in going there and sharing and discussing it. And suddenly, this physical equipment is not even running, but because there is a simulation behind it, but it was the core of condensation that all these things were happening because all of them were contributing to the same physical unit that is not even running. So everybody knew what to do. And it is a huge ecosystem now with virtual sensors, with wireless sensors, with automation systems, with IoT, with everything. And the core facility is not even running because it's on simulation mode. So I think this could be also maybe done with not a pharma-specific core facility part, yeah. But you can't cover all the topics like Ron was mentioning because it's just one unit operation. So you can play that and you can cover specific topics. But I was really surprised how this piece of metal attracts people. If it's not running. So somehow, obviously, we as a mankind, we need something physical to realize the digital. This is some learning. That was really interesting. So
that's interesting. That's interesting. Yeah.
Oh, that's
honestly,
really
Ron, we came into contact with Nybert, which is, I think, the biggest training center in the pharma industry with about 4,500 trainees per year. And they said, hey, it's cool. We have a kind of a digital trainer, but we want to have it on that facility. And then we realized, well, the facility, it won't be there for the digital trainer, but still it helps us to create applications, to create all the scenarios. So this was really something where we said, well, interesting. We didn't think about that, but it was a discovery, I would say.
Thanks, Martin. So maybe I think we are over time, but in the interest of time, one last comment from all of you, and especially from the student point of view, what are the career prospects in a digitalization going ahead? Any last thoughts? Maybe let's start with Pinak, the other way around. Pinak, any last thoughts about digitalization careers? What should students be looking for?
I guess plenty of options for students. I guess becoming like data scientist for BP, data scientist for Exxon, data scientist for McKinsey, right? Like we look for people who not only bring in the data science expertise, but also are reasonably sharp, right? High IQ people, right? So that is where, like, and not necessarily a computer science background, as I was saying, right? Like data science, machine learning, AI, IoT, all these fields are open to everyone, right? Irrespective of domain. Now, of course, if you have a chemical engineering degree from say IIT Bombay, you have a head start. You have a head start over the 99.9% anyways of engineering graduate, and you have a head start in the chemical industry, particularly from the other 5,000 people who are also cleared JEE with you, right? So therefore, the potential career path are basically with BP, Exxon of the world, in MNCs, Sadara, right? Saudi Aramco's and like Aspen, why not, right? And McKinsey's of the world. And also, if you look at the Indian companies, also they are paying very well, right? To in all honesty, I mean, you won't expect I mean, you will be surprised at how well even like mid-sized Indian chemical companies have started to pay. And in many levels, they actually match McKinsey, by the way, which is like really surprising. But yeah, that's where the world is going. That's where the world is going. So really, like, I know people of chemical engineering students particularly get disappointed to say the starting salary is say 7 lakh, 8 lakh, 10 lakh, but in 3 years it can go to like 5x of that, 7x of that if you are doing well, and even more. So yeah, so no dearth of opportunities. I think we should be just upbeat and happy about it. I think not necessarily about
Thanks,
it.
Pinak, for that positive note. What do you, Martin? What are some concluding thoughts on the whole issue?
Yeah, I think it's a combination of a technical domain which your chemical engineers will have, and the willingness and the ability to apply these modern and new technologies. Either you know Python a little bit, or you can somehow program and code, or at least you're skilled and you're open to learning different tools out of the digital domain. And I think it's easier having a technical background and you know how to make your hands dirty in a specific technology, and then learning the software part than the other way around. So I think that we have a good foundation, because the young people, as how they run their smartphones and things like that, I think they're willing to test new things, they're willing to interact. I think it's one driver for the software developers, as the big industrial ones, as also Aspen is. How do we tune our software in terms of gamification and stuff that the usability gets way better? I still think we're behind. Just imagine, Ron, I haven't seen the latest version of Aspen Plus. I have to be serious, but honestly spoken, I come across a lot of different industrial software, and compared to what we use as private persons, we're 20 years behind. And I think this is also something where we can support the acceptance of digitalization and the use of digital tools for people out of other domains. So I think I'm totally convinced with Pinak. Do your PhD or do your degrees in chemical engineering, look a little bit over the edge to control theory, to AI, to data analytics, and then you might find your job in any local or multinational company. We all are looking for people that have this interdisciplinary approach.
Thanks, Martin. Great. Over to you, Ron. What are some last words of wisdom?
Thanks, Rahul. So just as my last word, I'll start off by saying thanks again for inviting me, and thanks to all the students for listening. This has been a great conversation. Feel free to contact me personally if you want, anybody who's online. So yeah, so I think a couple things. We talk about in our company as from software, as Martin talked about it, there's the digital native generation, and then there's the older people. When I started working, if you guys can believe it, we didn't even have cell phones, or mobile phones of any kind when I started. So the world has changed. So you guys have an advantage coming out of school. You are digital natives. So you are the future of digitalization. So you should feel confident whatever job you go into, there's a huge opportunity to make change immediately. Second thing is, I'll talk about, as we say in the US, the elephant in the room. So the elephant in the room is, as a chemical engineer, your biggest opportunities are in areas like, oil and gas, chemicals, engineering, pharmaceuticals, things like that, mining. Well, you may say, why would I want to go into that industry? I'm ruining the world with putting carbon into the air and all these things. But it's really I say it's the contrary, that you can influence. I can say after a whole career, you can influence better from the inside than from the outside. So I think there are great career opportunities in all these industries, oil and gas, chemicals, pharmaceutical, metals and mining, because the companies themselves know they need to change. And if you think about it, who has the money in the world to make the change? It's these big companies. So they're the ones who are actually going to create the change. And you as digital natives have the opportunity to influence that change. But I think the final thing I'd say is, as people coming into the workforce today, you need to prepare yourself. Just because you've gone through your years of education, you're not done. I think what we've all learned in the working world, all of us who are in business, you're going to need to constantly re-educate yourself. So you're now in the mode of studying, you're going to go into the mode of working, but keep your study mode on, because I think people who can constantly retrain themselves and have that what we call intellectual curiosity to understand why and not just do what someone tells you in a job will be the ones who succeed and thrive in this very rapidly changing world. Yeah.
Thanks, Ron. So with that, I think, yeah, we ran over time, but it was a very interesting conversation. And I thank all the attendees for staying with us in spite of running over time. And thanks to Kriti and the organizing team for putting this event together. And yeah, have a good rest of the weekend. Kriti, anything else?
Yes, thank you so much, Professor Nabur. And Mr. Pinak, Mr. Martin, Mr. Ron. I think it was a very interesting lecture. I actually had a lot of fun listening to it. So I thank you very much, and I thank all the attendees for listening to us. So now I would like to call upon Manan Kasana, who is our overall coordinator, to present the concluding note.
Yeah, thanks, Kriti. So, hello everyone, I'm Manan, overall coordinator of AZOP. So, it's very much concluded by Professor Nambar, and I would like to thank Professor Nambar for the same, for moderating the session so well and discussing some really insightful points. And thanks to the other panelists as well, Mr. Martin, Mr. Ron, Mr. for providing great insights about the potential of digitalization, how is it enabled by the industries, and how universities can provide facilities to make students more available. So it was a very interesting session. I hope everyone enjoyed it, all the participants as well as panelists. So thanks for.
Okay. Thanks everyone. It was a pleasure having this conversation. Yeah. Bye guys. See you.
Okay, bye-bye.
Bye.